Okay, hi, hello everybody. So what I want to do now, I want to explain a little bit about some statistical ingredients that we will need in this course. So there, there is this general theory about probability and statistics, but in this course you don't need to know it. All you need to know is just the basic for the formulas for time series. So when we talk about time series, we talk about historical data of stocks or historical data of some other financial instruments. And what we want to understand is the interaction of these instruments between among themselves and the interaction of these instruments between each other. So we are going to denote the series by x1 to xn. So let's say if we have 5 days or 5 years and we have, let's say, return of S&P, right? So we will have 5 numbers, let's say 5% first year, 6% second year, and then we have 5 numbers. So let's say another 6.5% third year. Then we have 7% and then minus 10% the fifth year. Okay. So if we have a series like that, there are two major things that we need, that we want to find them, because if we have, let's say, 1,000 data points, we want to describe it not with 1,000 data points but with less numbers. So there are two numbers that we want to describe it by. So first of all is the average, which is given just by as a sum divided by n. So this is going to be the expected value or the average. So in this case, for example, we are going to have the average return, right, which is kind of one of the most important metrics for stocks, is going to be 5% plus 6% plus 6.5% plus 7% minus 10% divided by 5. So when you add them up, you are going to get 11%, 17.5%, 24.5% minus 10%. So you are going to have the average return is 14.5% divided by 5. Okay, so whatever this number is. Now, this is the expected value, and this is the sum of the returns of the series divided by n. Okay, and then the other thing is actually measures the randomness or the deviation of your series from the return. Okay, so for example, if you have a target arrow and you throw darts, right? So you want to actually hit in the middle. Okay, but let's assume that you will not hit in the middle. You can hit very close to the target, right? Or you can hit all over the place. And what the variance is going to measure, right, is how close is your series to the average. Okay, and the closer the series to the average are, right, the less random they are. So this is kind of the major thing here, is to measure the amount of randomness that you have, and this is measured by one number which is called the volatility, right? So what is going to be the formula for volatility? The formula for volatility in this case is going to be, so if you have x1 to xn, okay, then the variance of x is the expectation of x squared minus the expectation of x squared, or in forms, you are going to have that this is going to be xi squared divided by n, I go from 1 to n, minus, and here you are going to get that this is xi divided by n squared. Okay? So in this case, for example, in order to calculate this, we're going to have that in our case, in our simple example, right? How do we calculate the xi squared? So we're going to have 5% squared plus 6% squared plus 6.5% square plus 7% square and then plus 10% square, because minus 10% square and plus 10% square have the same square, okay? Because minus x squared equals x squared. So we just need to remember that minus x squared equals x squared. So in this case, you still divide by 5, okay? But you can see that you are actually calculating the average of the squares, and then you are going to subtract this number in a square, okay? So that's going to be your variance, and then the volatility, your sigma, is going to be the square root of the variance. So in terms of the data series, you are going to have that sigma is going to be the square root of the sum of xi squared divided by n minus xi squared divided by n. Now, lucky for you, you don't need to calculate volatilities, because in R or in Python, which we will work in R this case, we're going to basically have functions given the series to generate the volatilities, okay? Now, the other concept that we need is a covariance of two series, which is xy, right? And the formula is expected value of xy minus expected value of x times expected value of y, or in terms of a series, it is going to be the product of xi divided by n times the product of yi divided by n, okay, minus x, and so this is going to be the expected value of xy times expected value of y. Now, expected value of xy is going to be the sum of xi yi divided by n. So you first multiply x1 by y1, x2 by y2, etc., and then you subtract the product of the sums. And this is called the covariance of xy. And if you take the covariance of xy and you divide by the standard deviation of y and the standard deviation of x, you're going to get a correlation, rho of xy, okay? So this number will always be between 1 and minus 1. So if rho xy equals 1, what it means is that x and y are actually, they don't have any randomness involved in them. They are moving in tandem. So if x is going to move by 1%, you probably know that y is going to move by 2% all the time. Now, if rho xy equals minus 1, it means that they are going in the opposite direction, completely in a determined way. Now, in the middle is where you have the randomness, which involves x and y. And we will discuss regression, and you will see how these formulas are actually manifest themselves in regression. So once again, I'm not expecting you to know these formulas. What I do expect from you is to actually know how to calculate and to use these functions in some software program to calculate them. So that's the goal of this unit, that we will take these formulas and we're going to learn how to calculate them, okay? All right, so I hope that this actually explains somewhat what are those mysterious sigmas and variances and the covariances, and the next video we will explain you about the regression and how to use R functions in order to calculate regression. Okay.